Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, this video is about the Tandy Radio Shack TRS-80 Model 100. I've done several repair videos on these, but never really a getting started type of video. I've noticed on the forums there seems to be a lot of new people buying these machines. And you know, when you get a new machine, you always have the same sorts of questions. It happens to all of us. You know, does it work? How do I test it? Is there any maintenance I should do now? How do I get data on and off of it? That type of thing. So I thought I would put together I just bought a Model 100 and now what do I do sort of video. So in this video, we're going to cover the Model 100, the 102, which is the same basic machine with some surface mount parts, and the Olivetti M10, which is exactly like the Model 100 with a different layout and a screen that tilts up. But it's like the sexy Italian cousin of the Model 100. So we're not really going to concentrate on the repairs. When we get to something that needs a repair, I'll link to another video that I've done, an in-depth video on that particular subject, and we'll just do kind of an overview here. So buckle up and let's get started. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. Head on over to PCBWay.com right now. Check out their 10th anniversary celebration. There are special coupons and drawings. Check them out now. So the first thing I like to do is a visual inspection, get an idea of, you know, maybe how the machine's been treated. The keyboard is a little dusty, but it's not grimy. The LCD looks nice externally. Look at the front of the machine. There's no switches or connectors or anything here. On the right hand side, we have the power switch, contrast knob, and the external power connection. We'll talk more about this later. On the back we have the reset button, serial port, printer port, modem connection, and cassette connection, which are very similar looking, by the way. Barcode port, and these two are switches for the modem. And if we look at the bottom here, we find this little switch, which will be hard to read on the video, but it says memory power. This connects the backup battery to the memory circuitry in here to maintain the memory. Without this switch on, the machine will not boot up, so you want to make sure that guy is on. Oh my goodness, I can't do that one-handed. We want to look at the battery compartment. Let's see if I can get zoomed in here a little bit. So this one looks nice and clean. It doesn't look like it's had any corroded batteries in it, which is a definite bonus. Sometimes these do have signs of corrosion, and that stuff can work its way everywhere inside the machine. And if we pop open this cover down here, we have the system bus connector and the option ROM connector. Now you may get lucky and have an option ROM left in it like this. This one, I happen to know what this ROM is. It is what the AP news service used, and I have permission from the owner of this, who's the original owner of this machine, to go ahead and dump this. I don't know if anybody's already done that already, but everything visually from the outside looks good on this particular machine. So now we're ready to prepare to power it up. Before trying to power up our Model 100, most of these have spent years sitting in a closet somewhere or in an attic, and that memory backup battery is completely dead. And if that guy's dead, this machine will not boot, because that battery not only keeps the contents of the RAM alive, it powers 2 or 3 other chips in there that are involved in the reset process. That way when it resets, it's not going to clobber the RAM that we're trying to back up. So what we want to do is power this thing up, or install the batteries, or use the wall wart. Don't try to turn it on, just put the batteries or connect the wall wart. Let it set for several hours, maybe even overnight. Most of the time, even if the memory battery isn't very good, that will recharge it enough that it'll allow it to go ahead and boot. If you got the original AC adapter, it'll look something like this. It is a 6 volt, 400 milliamps center negative. Now, these older adapters like this were unregulated, which just means it has a transformer, a bridge rectifier, and a capacitor in here. There is no voltage regulator. So this rating means that at a 400 milliamp draw, this is going to output about 6 volts. With less current draw than that, the voltage is going to be a little higher. I did a whole video on how to select modern power adapters for our vintage equipment. I'll link to that below. For this particular machine, I'll give you a cheat sheet sort of thing. You can get a modern 6 volt adapter, center negative. It is a 5.5 millimeter OD, 2.1 millimeter ID, and again, center negative. That is very important. They come in both flavors, and you want to make sure you get the right one. So I'm going to plug this guy in to the jack on the side and let it set several hours, and then we'll come back and actually try to fire the machine up. All right, I've had this guy plugged into the AC adapter for several hours now, and we're ready to start charging. The power switch is pointed back away from me, which is off. Toward me is on. And I've got the contrast knob, which is right here in about the half position. I'm going to go ahead and slide the switch toward me to turn it on. And I'll adjust the contrast here to get you a good as picture as possible. Maybe I can rotate this up to make it work a little better. That's about as good as it's going to get. So as you can see, we got lucky on this, even though it thinks it's 1912. It does work. The display came up. What if the display does not come up? If the display is black, that means you've got the -5 volt rail working, but the machine is not booting up all the way. If it doesn't boot up all the way, it just stops. There's something wrong that's preventing it. If the display is blank, it might mean that it's getting further through the booting process. It might be booting up all the way, but you don't have the -5 volts, so you can't see anything. What you can do then, if you have a blank display, is, if you can imagine that we can't see this. There, I turned it all the way down so you can't see it. I'm going to press enter. That'll take us into basic, because on a freshly reset machine, basic should be the lowest thing alphabetically. And then I'm going to type beep. And ideally you'll hear it beep. And if you don't hear it beep, it could mean the machine has not actually booted up, and it could mean that the beeper is bad, which is the case on this machine, I believe, because it does indeed boot up. And you can see I typed beat there, or not beat, beep. Now we know this machine seems to be in pretty good condition. It's booting, so most everything's probably working okay, but we're not out of the woods yet. We're going to have to get into seeing what we need to do in the way of preventative maintenance before we call it good. Now let's go ahead and take this apart to have a look at the insides. There are 4 screws, 1 in each corner. This is going to be similar on all 3 machines we're talking about. I'm missing 1 screw here. Rotate the top over like this. So we've got our LCD and keyboard here. Oh, we've got the speaker disconnected. So that was obviously done on purpose. I think he wanted me to reconnect that. And we can go ahead and disconnect the top half by unplugging these. Note that we've got the red stripe here. Red stripe. And this is pin 1 up here. It goes right like that. It's marked pin 29 and 30 here, so that's opposite of the red stripe. White connector here, black connector here. I like taking the plastic spudger, giving those a little bit of a twist to get them started. Sometimes they're really not wanting to come out. Okay, now we've got our bottom half with all the goodies in it. This one's got a full complement of RAM. This is a third-party RAM. The original looks like this. These original RAMs are a pretty good failure point on these machines. They can stop it from booting. Got our ROM here. Lots of glue logic, processor, I/O chip for the LCD, parallel port, that type of thing, and this is the UART. You notice we have a whole slew of electrolytic capacitors in here. And yep, we've got some leakage going on. I'll get you a better shot at that. And we've got the memory battery right here. The memory battery is a pretty straightforward swap. These are made by Yaesu. They don't leak like the Vardis do that destroyed Amigas and whatnot. They can leak, however, and they're 40 years old, so they need to be replaced. I always keep these in stock, keep the capacitors in stock. So I'm going to get you a shot of the board from kind of the view you'll have of it, and we'll look to see what the evidence of leaking is. So we're over toward the left-hand side of the machine here. And you notice these little bitty capacitors. These are all 10 microfarad. These are the worst offenders when it comes to leaks. And you might look at this and say, well, it doesn't look too bad, but you notice this looks kind of dark in here. It's not bright green like this. And this scrapes off pretty easy. So these capacitors have been leaking. That's going under the solder mask, and it is eroding away the copper. I've got these 4 capacitors here. These are all non-polarized. They really don't leak, but when I replace the caps on these, I do the whole shooting match. So everything done at once. This is the power supply section. And there's a lot of leakage typically up in this area. Yeah, you can see how that's working up here, and that solder mask is just flaking off. Down in this area, there's some little traces here that tend to get corroded away, and even up into here sometimes. So I'll link to some videos where I show recapping these and taking care of the damage that it causes. You've got to get every last speck of that corrosion off there. It'll keep eating through the board. I'm going to recap this guy, replace the memory battery, and then we'll continue doing some testing. One other thing I want to point out, this is the serial port output section of the board, and there are 3 resistors in here we want to check. There is a Radio Shack service bulletin on this from May 1983. I'll put a link to this document below. And they put 2 larger resistors in here. These are in series with the output of the 3 serial lines, the transmit line and the 2 output handshaking lines. They originally had some like 4.6K resistors, 5.6K resistors in there, and they should have been 330 ohms. There is a serial number cutoff in here that you can reference to see if your machine needs it or not. I checked this one. It says it shouldn't need it. I double checked. And indeed, these are the 3 resistors. And instead of the 5.6K, we have the 330 ohms, which is correct. With those higher value resistors in there, you can have problems connecting to some equipment. Even if you do a loop back to check the serial port, the voltage is so low that it's on the edge of not working properly. So it's good to check those. Cheap and easy to replace those 3 resistors. I've got the board recapped, a new memory battery installed. I'll pop a couple of pictures up here of what it looked like. This is pretty typical. It wasn't too bad. Again, look in the description below for some links to videos where I've done an extensive tutorial on recapping these machines. Now, one thing I want to do before putting it back in the case is measure the voltages. You can see here on the board it marks ground, VDD, this is plus 5 volts, VEE, minus 5 volts, and VB. When power is applied, like external power, or you've got the 4 AA's in and it's turned on, VB is going to be about 4.5, 5 volts. That's the charging voltage going to the battery circuit. And when it's off, VB is going to be, like 3.6 volts, the battery voltage. So I'll get set up to measure this now, and we'll have a look and see how this board's doing. Okay, one reminder, this memory battery switch acts like a main power switch, so we need to have it on. It's kind of down toward the front of the machine where your fingers would be if you're typing. And then we can turn the power on. And I'm using my bench power supply now, and without the LCD attached, this draws about 52 milliamps. That's why I like using the bench supply. It gives you a good idea of what's going on. And here's ground, so here's our minus 5 volts. That's fine. And our plus 5 volts. That's fine. Our VB with power applied, okay. And there's battery voltage. This battery needs to be charged up. It's a little bit low. Just got it off the shelf and soldered it in here. So now I'm comfortable that the board is okay. We'll go ahead and put it back in the case to do further testing. We've got this Model 100 popped back together, and there are a few more checks we can do just to make sure everything's okay. I've got a couple of short programs here that are small enough they're easy to type in, which is what I've done on this machine. This is a burn-in test. It just reads all of the 64K locations from memory, and if they're printable characters, pokes them to the screen. And there's also a keyboard test, which just reads an in key string. If it's anything other than null, it prints it to the screen. So it's not a perfect keyboard test, but it's quick and simple to type in. So I'm going to go there we go. I set the contrast so it's visible on the camera, and I can hardly see it from my angle. Keyboard test. It's running, and if you press a key, it shows up on the screen. Interesting thing about the keys here on the top, if you press one, it actually acts like a macro and types out the command, which I find is interesting. And you can just go shift break to stop that program, and F8 to go back to the start menu. And here's the burn-in test. So it's just going to read from the entire memory map, poke that to the screen, and it keeps going. And it eventually, after it goes through all 65,000 in some locations, it'll beep the beeper if it's connected. This fellow wanted this one left disconnected. It was an interesting story as to how it got disconnected, or why, I guess I should say. But as you can see, this works. When I've had one of these that I'm working on that's been kind of flaky, I like plugging this into the AC adapter, letting it run overnight, just to make sure it doesn't lock up and everything's okay. Again, basic program, shift break, and we can stop the program, F8, go back to the main menu. One other simple test we can do is to check out the serial port here. We can use Telcom for that. And we want to do, well, the settings really don't matter for the first part of this, but we'll go ahead and set them for the second part. We'll do stat 98N1BNN. This just sets it for 19,200 baud. No parity, 8 data bits, 1 stop bit. Okay, and then if we go F4 to go into terminal mode and press F4 again, we want to go into half duplex. Now the computer will print to the screen every key I type. Okay, if we go into full duplex mode, it's going to expect that the receiving computer will echo back the character. So if I keep typing, nothing happens. And one simple thing to do is loop back pins 2 and 3. This is the transmit and receive. That's what this little dongle here I wired up do. You can also just carefully poke a couple short wires in here. Because my loopback adapter was made for an Amiga, it has a female connection, so using this male-to-male adapter, we'll plug that guy in there, and now in full duplex mode, it is sending the data out. It's going through the loopback adapter here and back into the computer. So we know at least transmit and receive are working, but this doesn't let us know about the handshaking signals. The easiest way to test those is to use a null modem cable connected to your computer with a terminal program. So let's look at that now. Got the null modem cable hooked up. Had to use 2 gender changers because this shell's a little too thick to fit in this slot. Makes it a little precarious, but it works. So we'll fire up Telcom again. And the first thing to notice, I'm going to hit F4 here. Our connection's still fine from when we set it up before. Is that when we connect, the handshaking lights on CoolTerm will light up. So we'll go F4. Our handshaking is all fine, so we know those work. And on the PC, I can type from PC. Oops, that wasn't the enter key. So I got a couple silly characters there because I hit the wrong key. And then on the Model 100, we can say from M100. You notice that on the Model 100, it only did a carriage return. It didn't do a line feed. You can go Control J and get a line feed. On the PC, it did both. This is something weird on the Model 100. I tried a T102 and it does the same. But we can see that our serial port is working. We can send data both ways. The handshaking signals work. So we should be in good shape. So after you get your Model 100 or 102 or Olivetti M10 working, the next task someone usually wants to do is get programs and data in and out of it. And of course, one option is the cassette port. Then you've got to find a way to convert your files you might find online to WAV files, connect them to find the cassette cable connected to your computer, etc. And a lot of times cassette loading and saving can be finicky and it's rather slow. Back in the day, one of the most popular options was the Tandy portable disk drive. I'll pop a picture up here, which was a battery powered 3.5-inch disk drive. it came with a very minimalist DOS that worked, but it wasn't super convenient. And then a company called Traveling Software came out with TS-DOS, which was menu-based and it was much better. And you would have gotten TS-DOS in the form of a ROM that plugged into the option ROM socket, which would look kind of like this one. Today, we've got a couple more convenient options. One is a Rex. This is an older version of the Rex called the Rex Classic. This is quite a slick little device. It lets you load multiple ROMs onto the flash memory on here and activate them one at a time. It'll back up the state of the machine, all the RAM and everything. Quite nice. I'll put the link to where you can get the current version. Another option is the Dial-A-ROM. This is a large flash memory device with 16 banks that you can select with the dip switch, and there is a different ROM in each bank. So you can still only activate one at a time. It plugs in just like this. You set it to the ROM you want. Position F here is TS-DOS from the Model 100. There's a PDF that comes with it, which shows you what to type in to activate the ROM. And then if you want to switch to a different ROM, you deactivate that ROM, turn the power off, rotate the switch, etc. So the Rex is more powerful, it does more, it's more expensive. The Dial-A-ROM is simpler and cheaper. So you've got an option there. And these I sell. I'll put the link to these below. Both work great. And then after you have TS-DOS installed, you can get yourself a device that'll use TS-DOS, like a Tandy portable disk drive 1 or 2. Using a 3.5-inch disc is a little nicer than using a cassette. They have a limit of 100K or 200K per disc. There used to be a device called a NADS box, New Age Digital Storage Box. And then about 3 years ago, a friend of mine invented the backpack drive, which is, and it takes a micro SD card and it presents itself to the computer as a Tandy Portable Disk Drive 2, but with a virtually unlimited size. So, you know, you can install just about everything ever written for the Model 100 on one card. And it runs on one AA battery, and it just plugs into the serial port in the back. Power switch. It's got some status LEDs over here. So, and this will also work with the Model 200, the NEC slab tops, and some others. So I'll put links to the product page and videos I've done on this device in the description down below. In addition, you can get PC-based programs that act like act like a Tandy Portable Disk Drive 2, that you can run on a PC, and you can connect your computer to the PC with a serial cable and go that way with TS-DOS on here. Oh, I should also mention, if you don't have a TS-DOS ROM, you can also bootstrap it off of the backpack or over serial. The problem with that is it eats up a lot of RAM, so you need at least one additional RAM module in your computer. You want at least 16K on here, because I think bootstrapping TS-DOS takes like 5K. And the one big thing to look out for then is this: a lot of times people find a program, you know, program.ba online, and they'll stick it on the card and they'll try to load it on there, and they'll only get the first 2 lines, which are garbled, or it locks the machine up. Back in the day, when people shared these programs on BBSs, you could only use text files. So they would share text files named .ba for basic, even though it was not a tokenized basic file. And people just knew that back then, and now people don't. You know, they don't remember that, or they didn't know it to begin with. So if you can open up the file and it reads in plain text fine, it's a text file, and you'll need to load it as a different file type on your Model 100. I cover that in the video. I even show in the video how to use the backpack command line interface to determine what file type it is and rename the file to the correct type. So just a little gotcha there that everybody, including myself, has fallen into probably more than once. Well, there we go. We've got another Model 100 up and running. It's ready to go for another 40 years. And we've covered a lot of the things that you need to know when you're first getting started, what to look for on the machine, and some links to some videos about how to recap it, replace the battery, that type of thing. We've covered some simple tests you can do to see if everything's working okay, and some multi-ROM sorts of options, as well as how to get programs and data into and out of your new Model 100. So this hasn't been an all-encompassing, all-exhaustive video, but it should be enough, hopefully, to get your foot in the door and get you started using the machine. So in the near future, I'll also do one on the Model 200, which is going to be very similar to this, with some of the quirks of the Model 200 covered. If you have any questions or comments, I would love to hear from you. Leave them in that comment section down there below. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means. It's greatly appreciated. And until next time, bye.